Hello, my dear students. Here I have come up with another video on GATE Civil Engineering, that is called the moment of inertia, area moment of inertia or second moment of area. But before starting of this video, I will request you to see the video of on basic formulae which is given in the description box. So please go through that video. After that only start with this video. Okay, now what is area moment of inertia or second moment of area? It is the property. Okay, it is the property by which we can understand that for a section how the points are distributed. Matlab, what is the meaning of it? Moment of inertia, area moment of inertia. Please remember this term. Here I am not discussing about the mass moment of inertia. Here I am telling you about the area moment of inertia. So area moment of inertia means that when we give a loading to a beam, the beam bends. Moment of inertia gives the idea of that section to resist the bending of the beam when we are giving some loading. Understood? I repeat it once again. When we load one beam or any structure, it goes through bending. Okay, so moment of inertia gives us idea about the section which can resist the bending due to loading. So it is the property of a section. Okay, so now let us start with this. I have chosen some problem, as you can see in the board. 1 2 3 4 4 gate problems, previous year question I will discuss. Few are from civil engineering paper, few are from the mechanical engineering paper. Okay, please see my basic the video I have mentioned and that is given in the description box, basic formulae. वो वीडियो देख लो, फिर ये चालू करो. ठीक है, तो बेसिक जो डेफिनेशन है वो मैंने बता दिया है. नाउ आई विल एक्सप्लेन यू अबाउट द पैरेलल एक्सिस थ्योरम बेस्ड ऑन व्हिच वी विल सॉल्व द प्रॉब्लम. what do we understand by the parallel axis theorem? Now let us concentrate on the board. See, parallel axis theorem, is it okay for you? Yeah, parallel axis theorem. Parallel axis theorem means what? Suppose this is a body. Okay, this is x axis and y axis. What is g? G is the centroid. Centroid means the center, geometrical center of a body. Now this is gx and gy are the centroidal moment of inertia. What is small y and small x? Small y is the distance between x axis and the centroidal axis. What is x y axis and the centroidal y axis? There are two axes. One is ox and oy. There is another set of axis which is gx and gy, right? So x and y I have explained. Now what does parallel axis theorem states? Parallel axis theorem states that an axis which is parallel to the centroidal axis, moment of inertia of that axis can be found out by adding centroidal moment of inertia plus area multiplied by the distance between the two parallel axes. This is the statement. Okay, what do we understand by it? Suppose this axis ox is parallel to gx axis, so moment of inertia about ox will be igx, that is the centroidal moment of inertia, plus area, that means area of this body, multiplied by the square of the distance between the two parallel axes. This axis, what is the distance? Distance is y, correct? So this is y square. Similarly, IOY is equal to IGY plus AX square. These are the parallel axis theorem. Based on this, we will solve these four problems. Before starting, again I am telling, please see the video of basic formulae where I have discussed about the different formula which I will be using in this video. Okay, so let us start. Problem number 1. Problem number 1, you can see it on the board. What is the problem number 1? There is one rectangular section B, width is B and the depth is small d. The problem is clear. There is one rectangular section, width B and depth is small d, at a height d by 4 from the base of the rectangular section. We have to find the moment of inertia. This is gate problem. Is the problem clear? Moment of inertia at a distance d by 4 from the base of the section. How how we are going to solve it? Please try it. We will solve this problem using the parallel axis theorem. How we are going to solve it? See, what is IGX we know. Okay, this is I. This is, suppose we name it as AB. If we name it as AB, so IAB, we have to, so from here, how we can find it? That will be IGX plus A y square. This formula we are using. What is IGX of a rectangular section? What is IGX? IGX is equal to 112 B D cube. Please see the earlier video, there I have mentioned. Rectangular section centroidal moment of inertia is 112 BD cube plus, what is area? Area of a rectangle is equal to B into D. Is it okay? What is the distance y? What is y? Y is the distance between the centroidal axis and that axis. So here one second, where we have to find? We have to find the moment of inertia about d by 4 from here. So this is AB, right? This is AB. This is AB. Now what is the, see, this is the centroid. What is the distance of the centroid from here? Distance of the centroid is d by 2 from the base for a rectangle. Okay, this is d by 4. So what is y over here? Y is the distance between the centroid and the axis about which we are taking moment of inertia. So AB, what is the distance between these two? These two will be d by 4, because total is d by 2, this much is d by 4, so this much will be d by 4. So it will be d by 4 whole square. So how much it is coming? So please see the answer, solve it and tell me in the comment box that whether you are getting this answer. 7 by 48 BD cube. I hope you have understood. This is B. We have to find out the moment of inertia about AB. AB is at a distance of d by 4 from the base. The centroid is at a distance of d by 2. This is G. So total is d by 2. This is d by 4. So this is d by 2 minus d by 4. That is d by 4. So that square. So this is the first question. Let us go through the second question. What is the second question? This is a square. This is a square given of unit meter, 1 meter, 1 meter side. We have to find the moment of inertia about its diagonal BD. Moment of inertia about its diagonal BD we have to find. Is the problem clear? Now, if you see that we know the moment of inertia, about the centroid of a circle. Centroid of a rectangle, about the base of a rectangle, but we do not know the moment of inertia about its diagonal. So we cannot apply any direct formula. So in that case, how we will do it? So let us see. So for this problem, let us draw the diagram, redraw the diagram like this way. So if we just rotate it like this way, if we rotate it just like this way, so suppose, so this will be B, this will be D. Matlab aise, we are just rotating it like this. So this point will be C, this point will be A. We are redrawing. We are redrawing the same thing, just rotating. Now this becomes what? This becomes the BD diagonal becomes like this. Now we know that for a square, this is 1 meter, this is 1 meter. So this will be, the diagonal will be √2, correct? So DB, this diagonal is √2. AC is also another diagonal. AC is also another diagonal. What is the value of AC? The value of AC is also √2, correct? Another diagonal. So what will be? See, this is √2. Then what will be this much? This much will be 1 by root 2. How? Root 2 by 2. Root 2 by 2. Half of root 2. That means 1 by root 2. Now this becomes triangle. Now we know what is the moment of inertia of a triangle about its base, right? So we can find out the moment of inertia about BD is equal to how much? 112. What is the moment of inertia of a triangle about its base? This is 112. B. What is the base? Base of the triangle, root 2 into what is the height? Height is 1 by root 2 is ka cube, and this is, there are two triangles, so into 2. Have you understood? What is moment of inertia of a triangle about its base? Now it becomes the base. So 1 by 12 root 2 into, this is the base. What is the height of the triangle? 1 by root 2. 1 by root 2 whole cube. And there are two triangles, correct na? So 2 into 2. So this becomes the moment of inertia of this square about its diagonal. And the answer comes out to be, I will write down the answer. Please let me know in the comment box whether you are getting it. 1 by 12 meter to the power 4. Please let me know whether you are getting it. Okay. Now we will go to problem number 3. Please see the problem. This is one rectangle, 60, okay. This is 120. Through the center, one axis is passing, that is xx, and all the dimensions are written in millimeter, right? All the dimensions are written in millimeter. Now these are the, from this rectangle, two rectangles has been cut. 30 by 45. This is also same, 30 by 45. Two rectangles has been cut or deducted. Okay, now we have to find the moment of inertia about this shaded area, that shaded area about xx axis. This is another year problem, gate problem. Tell me how we will solve it. Please try it. See, if we name it as A, B, C, D, right? A, B, C, D if we name it. So what is moment of inertia of A, B, C, D? That will be about the centroid. Okay, this is the x-axis is the centroidal axis. So it will be 112 60 into 120 cube. Whether you are getting it or not, please tell me. Okay, please let me know in the comment box. 1 by 12 60 into 120 cube. This is the entire rectangle moment of inertia. Now from here we have to subtract this and this small rectangle's moment of inertia, right? So what is the moment of inertia of this small rectangle? Let us name it as P, Q, R, S. Now moment of inertia of P, Q, R, S, that will be 112 B D cube, right? 1 by 12, 30 into 45 cube. Is it okay? This one rectangle, okay, this. Now you have to be very careful. From here, see, for the bigger rectangle, the centroidal axis lies within the centroid, but the smaller rectangle, इसके लिए इसका center कहाँ पे है? Centroid इधर है, correct? But the total system का centroid is over here, so you have to find the distance between this and this axis. That means, understand it over here. You have to find this distance. This distance. How we will find it? Tell me. See, total is 120. So this much is 60. This much is 60, right? This much is 60. Out of that, this much is 45. So how much is this much? From here to this. This is how much? This is 7.5. Have you understood? Total is 60. 60 से 45 minus करो, 15 हो जाएगा. 15 मतलब इधर 7.5, इधर 7.5, right? Now this is 7.5 and from here to here this is 22.5. 22.5 कहाँ से आया? 45 का half. That is 22.5, right? So from its centroid to here, this much will be how much? 22.5 plus 7.5, 30. Okay. So plus area of this please let me know that whether you have understood it. Now the final answer will be MIXX. MIXX will be MI ABCD. if this minus subtract करना पड़ेगा ना, because these two small rectangle MI has been removed, so minus, but this is for PQRS. Similar for this upper rectangle also, so the entire value we should multiply it by 2, so minus 2 into moment of inertia of PQRS. Please let me know whether you have understood it and tell me the answer in the comment box. So the final answer is coming. I will write it with the black color. That is 6.88 into 10 raised to 6 millimeter raised to 4. See whether you have understood it or not. Okay. Now the last problem I will come. Last problem I will explain over here. See the problem number 4. Problem number 4, it is given. So this is also one rectangular shape. From that rectangular shape, 2 semicircle has been cut. Now the shape becomes like this. So you have to find the moment of inertia about its base AB of this shaded area. Is the question clear? This is also GATE 2016 paper, question paper. So you have to find the moment of inertia about AB, right? Tell me how we are going to solve it. This is a very good question. So again, let us start. Okay, just like the previous problem. Now moment of inertia, let us name it as ABCD, right? ABCD, right? So moment of inertia of ABCD, the bigger rectangle, is how much? 10 into, sorry, moment of inertia will be 112 into 10 into 10 cube. Is it okay? But here we are doing it like this way. See, this moment of inertia of ABCD, we can find it in 2 ways. Now this way, this is what? This is the centroidal moment of inertia. But we have to find the moment of inertia about its base. So we can directly use the formula of moment of inertia of a rectangle about its base, 1/3. This is 1/3. And if we use the centroidal moment of inertia 112 BD cube, then we have to do 112 into A into this square. By that way also you can do it. But for rectangle, circle and triangle, as I have explained in my earlier video, that please remember that formula. So this is 1/3 into 10 into 10 cube. Okay, this is now this semicircle. Now if this is 8, what will be the radius? Can you tell me what will be the radius? The radius will be 4, isn't it? The diameter is 8, so the radius will be 4, correct? Now for a semicircle, what is what is the centroidal moment of inertia for a semicircle? You can do it like that way, or these two semicircle forms a full circle. This problem is very, very conceptual and very tricky. So if you can do it in an intelligent way, you will end up doing it. Otherwise it will take much time and you may do mistake in calculation also. So these two semicircle consist one bigger circle. So one big circle moment of inertia is equal to pi by 64 d raised to 4. What is d? D is 8. Diameter is 8. So 8 raised to 4. Pi by 64, 8 raised to 4 plus, this is the centroidal moment of inertia, right? Now about AB, so you have to do area pi d square by 4. This is the area, right? This is the area. Now what is the distance between this center and this? This much distance is how much? You see, total is 10. Total is 10. This much is 8. So this much is 1 meter and 1 meter. Is there any doubt? This much is 1 meter. This much is 1 meter. So what is the distance from here to here? 1 plus this much is 4. So 5 into 5 square. This is the moment of inertia of circle consisting two semi-circles. This is very, very important. This is very, very important. So now what will be the final answer? MIAB will be, this is equation number 1, this is equation number 2. Equation 1 minus equation 2. Please tell me whether you have understood it or not. The final answer I am writing it 1875.6 millimeter to the power 4. Millimeter to the power 4. So please tell me how you liked my video. Please put a like button, hit the right button, like button if you have liked my video. Please subscribe my channel and please spread it to your friends if it is of any help. And for any clarification, you can come for online session with me. You can mail me at prof.megadatta@gmail.com, which is given in the description box. I also take personal tuition or guide you for the semester studies or for the GATE exam, whatever, civil engineering and few mechanical and architecture students. Some subjects also I take. So please keep watching and thank you for watching. I will come out with another video, another topic on GATE civil in my next lecture. Till then, bye.